Many movies and TV shows have a scene where a mysterious substance is found at a crime scene. So they take it back to the lab to figure out what it is. That's an example of elemental analysis. Elemental analysis is finding what elements that sample is composed of. And primarily, we're looking for the percent composition, which is the percentage by mass of each element in the compound. And for instance, you could have a sample that's 20% carbon and 60% oxygen and 5% chlorine and 15% hydrogen. That tells us what that substance is. Now, to find percent composition, we always take the mass of each element over the total mass and then multiply by 100%. And we can do this either for a sample of the compound or figure it out for a compound based on its molecular formula. Let's look at the steps to do it for a sample. So let's say we have a sample that contains 37.6 grams nitrogen, 10.82 grams hydrogen, and 95.14 grams chlorine. And we want to know what the percent composition is. So what we're going to find is the percentage nitrogen, the percentage hydrogen, and the percentage chlorine. Let's start with the nitrogen. But before we do this, we need to find out the total mass. So that's 37.6 plus 10.82 plus 95.14, and so that gets us 143.56 grams. This is what we're going to use in the denominator of all of our calculations. So let's figure out percent nitrogen. So we take the amount of the nitrogen over this total, 143.56 grams. We multiply by 100%, and this gets us 26.19% nitrogen. We can do the same thing for the hydrogen. So now it's 10.82 grams hydrogen. We have the same denominator. The denominator always has to be the same for all of these because the total is the same no matter which element we're talking about. And so this gets us 7.537%. I'm including 4 sig figs because I start off with 4 significant figures. Now let's go on. So we've done nitrogen, hydrogen. Let's do the remaining, which is for our chlorine. So our percent chlorine will be the mass of the chlorine, 95.14 grams, over the total mass, 143.56 grams, multiplied by 100%, and that gets us 66.27%. So that's the amount of chlorine. We have the percentage nitrogen and the percentage hydrogen. Let's do one last thing. So if I take 26.19, that's the amount of nitrogen, 7.537%, which is the amount of hydrogen, and I go ahead and I add in this 66.27% for the chlorine. I'm going to get 99.997%, or really close to 100%. And that's what we should get for percent compositions. We should get something really close to 100%. Why? Because these are the 3 elements that make up that compound. All right, so that's how we do percent composition. The goal is to figure out the percentage of each one of the constituent elements.